So today we get to finish section 11.3 since we didn't get done with that last time. And then after we get done with that stuff, I'm going to go ahead and start reviewing. You'll have your test next time over it, so we'll start reviewing for the final today. See how much of that we can start looking at and start looking towards. So today we have section 11.3 we finish. On Wednesday, we'll take the test. On Friday and Monday, we'll finish reviewing for the final. And our final in here is on Friday at noon. The last possible final. What was that? No, because Monday's not final schedule yet. And I'm supposed to give you your final during the finals time. Oh, so I'm going to make you lie for me. I'm not thinking that's a good plan. All right, so finishing up section 3. We ended here last time, but I want to make sure that we really stress what you're talking about here. When we're doing these contingency tables, our null hypothesis is always that the row and column variables are independent. Our alternative hypothesis is that the row and column values are dependent. Because most situations, unless you can prove that there is some sort of relationship between two things, the natural assumption is that there's no relationship between two things. If I was trying to look to see if there's a relationship between your height and your GPA, the natural assumption is there is no relationship between those until I can somehow show that there really is some sort of correlation between them. And so when you're looking at those, whether it's talking about on the best fit line when we were looking at regression equations in chapter 10, again, our first assumption is always, our null hypothesis is always, that they were independent, that there was no correlation between them. With the alternative hypothesis in chapter 10, that there was a correlation. It had to be strong enough out there on the p-values, had to be so extreme, or I guess it wasn't the p-values we were looking at, our correlation, our regression, our R value had to be so extreme, correlation coefficient had to be so extreme that we were able to say, yeah, there really is a relationship between those. Or in this case, we're going to be looking at finding those, trying to calculate things up and trying to decide, is there some sort of correlation between those that we're looking to see if they're independent or if they're dependent. So you're always assuming things are independent unless we find out otherwise. So to do our test of independence, we're going to be doing a chi-squared test. So notice this is coming from when we're looking at having that categorical data, we're looking at how many we're observing in each of these different things. To figure out our test statistic, which is the chi-squared value, it is the sum of the difference between what was observed compared to what was expected, squaring those values over what we actually expected, where O is the observed frequency in a cell, and E is the expected frequency found by evaluating. The expected value is the row total times the column total divided by the grand total. So we're expecting, using the fact that we're assuming there is independence, then the total row total we would expect to not change if there was no relationship between them. The total amount of column totals we would expect not to change if there was no correlation between them. And then we're just, so that would figure out what would be the average number you would expect in that cell. And we're just looking at what's that difference between what we really saw compared to what we would have expected to have seen had there been independence between them. So if we go back to number 8 on page 607, this was working with the baseball team, the Houston Astros, where they were wanting to be able to close their dome and see if that helped them win better. And we're trying to look to see, is there really a relationship between those? Does having the dome closed help them win more games compared to having their dome open? Is there that correlation between them? So first of all, if I am trying to figure out what my expected values would be, we have to figure out each of the row totals, each of the column totals. So just adding up my rows and my columns. To figure out what I would have as my expected values. So this is what was observed. They won 36 games when their dome was closed. They won more games when the dome was closed than they won when the dome was open. So they're going with the assumption that looks like that's helping us. But compared to the number of games, they lost more games with their dome closed than they lost with their dome open. So obviously in this case, they had more times when the dome was closed than when their dome was open. So trying to look to see, is there a relationship? Well, if I try to figure out what was expected, to figure out the expected, you're going to take the row total times the column total divided by the grand total, which I guess I didn't find what the grand total was. So we had 79 games that they played. So to figure out how many I would expect them to win when the dome was closed. I would take how many they played when it was closed times how many they won divided by the grand total of 79. Which means I would expect them to win 34.2. Questions there? I want you guys to do the other three. So you're going to take your row total times your column total divided by the grand total. So the grand total of 79 is not going to change on any of these. And I guess to keep me from having any kind of rounding error, I probably should keep a couple extra decimals. So let's go and do 34.215 just to avoid. All right, so what do you guys have for the closed losses? Okay, 18.785. How about for the open wins? And for the open losses? Okay, so this is what I would expect. If there was no correlation between them and I ended up having my team have 51 wins and 28 losses, and they had 53 times that the roof was closed compared to 26 times that the roof was open, I would anticipate that they would have 34 wins when the roof was closed. They would have 17 wins when the roof was closed. And so this would tell me what I would expect out of this. Well, now the question is, how far off is what I observed compared to what I expected it to happen? So if there is no correlation between these, how far off is this? And that's what this formula is looking at. What is that difference between what's observed compared to what's expected? Taking that difference and dividing it by what was actually expected is telling me kind of basically how far, that percent of how far off. Well, I guess it's not really a percent, so I'm squaring it. But it's giving me an idea of how far off it is, and I'm going to add all of those together. So I'm adding that from every single cell. And so as you're looking at calculating this one out, grab my paper so I make sure I keep my numbers as we go. To find chi-squared, I am taking that first cell I had 36 observed minus the 34.215 that I expected to see. I have to square that value and divide that by what I expected, which was the 34.215. That's what I'm getting from just that first cell. From my second cell of looking at when it was closed compared to the number of closed losses compared to what I expected to see. So I'm going to have to take the 17 minus the 18.785 squared divided by what I would have expected it to happen. And doing that for every single cell. And this is the reason why we need to keep some extra decimals, that I was having too much of a rounding error as I was doing it. Because with having to do the subtracting and the dividing, that if I only rounded this to 1 decimal, I would have some rounding error that I would run into. So I'm going to give you guys a moment to do the arithmetic. Be careful with your parentheses. You will have to put the parentheses around this part that you're subtracting first to square it, divide it by this. You don't have to put a big parenthesis around this whole thing because calculator will divide before it adds. So go ahead and do that arithmetic. All right, so as you're doing the arithmetic, you are coming up with 0.798 as my chi-squared value. That is my test statistic. Now, if it's a chi-squared value, what do you think we should do next? Okay, go to the chart. So if I'm going to my chi-squared chart, before I can use my little handy chart, what do I have to know? I need to know the significant level, and I also need what, Nathan? I need to know the degrees of freedom. So if we go back to trying to figure out our degrees of freedom, if I told you the totals for the rows and the columns, how many numbers would you need inside this table to be able to figure out everything else? If you didn't know anything else, if I didn't know the number of wins, losses, opened, closed, none of these, but I knew all the parts that are in red. If I gave you that they had 36 wins when it was closed, could you figure out the rest? Aaron's going with yes. The rest of you are just looking at me. Do you guys agree or disagree? Could you figure out the rest? How many losses how would you find the 17? Okay, 53 minus 36. Could we figure out the 15? 51 minus the 36, and then we could figure out the rest of them. So if you knew one of these values, you could figure out everything else. What if instead of 2 columns, what if I had one that had 3 of them, and I gave you all of those? If I just gave you this one number, could you figure out everything else? How many numbers would I need? If I gave you 2 numbers, could you figure out everything else? Okay? As you're trying to figure out how we're calculating out that this time I needed 2 numbers, this time I needed 1 number. If I made it a 3 by 3, I'm just kind of making up some numbers here. Would 2 numbers be enough? How many numbers would I need now? Will 3 be enough? Do I have enough yet to figure it all out? Not everything. If I had 4 numbers, would that be enough to figure everything else out? Because with these 2, I can figure out this one, which means I could figure out this one. I've got enough to figure out that one. I can figure out the rest of those. So it's not just always we can't just say it went from needing one number to two numbers to three numbers. The way we figure out these degrees of freedom is if I take the number of rows minus 1 times the number of columns minus 1, that product tells me my degrees of freedom. If we go back to our example, here we had 2 rows, we had 2 columns, which meant I was taking degree of freedom over here was 2 minus 1 times 2 minus 1. Well, 1 times 1 is 1 degree of freedom, which is what we said is all we needed was that one value to figure out everybody else. When we had 2 rows but 3 columns, then when I do the 2 minus 1 times the 3 minus 1, well, 1 times 2 gave me 2 degrees of freedom, which was the second one we did. This current one we have, we've got 3 rows, 3 columns. 3 minus 1 times 3 minus 1, 2 times 2 gave me 4 degrees of freedom. So it's fitting with what our common sense just said we were going to need. And that's what degrees of freedom is helping you figure out. It's just a formula to figure out how many data values do you have to be able to figure out everything else. And so as you're figuring out your degrees of freedom, it's the number of rows minus 1 times the number of columns minus 1. Also, we needed to know what type of test we had. You're always doing a right-tailed test, because you're always going to have a positive value. I guess with chi-squared, you always get a positive value no matter what. This is a right-tailed test when we're doing these. So these tests of independence are always right-tailed tests. So now when we go back to knowing, my chi-squared test statistic is the 0.798. This is my test statistic. What did we just say our degree of freedom was on this one? Okay, it was going to be 1. So we were taking the 2 minus 1 times the 2 minus 1, which was just your 1. What is my critical value? And let's do alpha at the 0.05, I'm guessing is what we were doing on number 8. That's what we use on almost everything else. Yep, it tells me the 0.05 significance level is part of the problem. So if it's a right-tailed test, is all 0.05 in the right tail? Yes, I don't have to cut it in half. So what is my critical value? Okay, 1 degree of freedom, 0.05 in the right-tailed test is going to be that 3.841. Questions finding that? Because obviously if this is a chi-squared table, we have to use the table to be able to have my critical value. So my critical value is the 3.841, which means if I have anything more extreme than that, that's where I'm going to reject it. Is my number, is my test statistic in the rejection region? Test statistic is 0.798. Is that a reject or fail to reject? Okay, this is a fail to reject. And I'm failing to reject my null hypothesis. But what was my null hypothesis? We always assume it's a test of independence. So our null is always that the two are independent. My alternative is always that they are dependent. So if I fail to reject that they're independent, what does that tell me? These things are probably independent. This is not showing me that there's enough relationship between these two. So this tells me that this problem's conclusion is that there is independence. In other words, it's all in their head that closing the dome is going to make them win, that there is not that relationship between those. Or at least the statistics are not saying that there is a strong enough relationship between them to make that conclusion. that by closing the dome, it's going to help them win. The technical term, because it would be that there is not sufficient evidence to warrant rejection of the claim of independence between winds and whether the roof is open or closed. It does not appear that a closed roof gives the Astros a substantial advantage. Questions on that one? I will be good with if you guys just tell me if it's independent or dependent. The book's answers will give you a little bit more on that, that independent or dependent is the main thing I'm looking for. Now, be careful. You cannot use this to conclude that there is a cause and effect link between the variables in question. Even if I had found that those were dependent, closing the roof does not cause the Astros to win or lose. It might help them, but it's not going to be a direct, because you close the roof, they're going to win this game. Doesn't give you that correlation exactly. The example I was telling you about, that, and I meant to bring those numbers with us to be able to use, is the Grundy County Health Department's test that they're doing right now, and trying to look, is there a link between whether people smoke and their opinion on some of these smoking laws that they're considering putting into place. Trying to see if there's a relationship between those. If you find that there is a correlation between those two, that there is dependence between them, it's not necessarily a cause and effect. That by being a non-smoker causes you to have a strong opinion on those new ordinances that they're thinking about. Dependent only means there's a relationship between those two variables. If you're trying to go for a cause and effect relationship, you have to set up your study differently. It really has to be a, I've lost the word that I'm looking for. Experiment is what you really have to set it up as, where you really are manipulating certain values. For example, you'd have to manipulate whether somebody is a smoker or a non-smoker, which there's not going to be very many studies where they try to force people to be smokers so that they can study what their effects are. And so there's a lot of those that trying to find that cause and effect link. They're trying to look for those kind of relationships and be able to say that there is a direct cause and effect link. Very difficult to do with a statistically sound method of doing things, because you really have to set those experiments up. Now, what you guys really want to know more than anything else on these is, how can the calculator do this whole thing? Because there is a lot of data manipulation that you really have to pay attention to, because ours was just a simple little 2x2 matrix. If you were doing the 3x3 matrix, you would have a lot more things to go through and do. So looking at how to use your calculator to do it, because I'm setting these up as a rectangular array of numbers, those are matrices, and that's how you're going to put it into your calculator. So to put it into your calculator, first thing you're going to do is go to the matrix, which is right below the math. So you'll hit second and matrix. You're going to arrow over to edit for matrix A, and you're going to put your matrix in. So let's go ahead and put this same data in. So this was our 2x2 matrix, and just go through and put the different things in. So we had the 36, 17, 15, and 11. By the way, the first part was telling me the number of rows by the number of columns. It should make your matrix look the same as what the other one was. So if you put your numbers in backwards and it looks different, flip them around. But it's always the number of rows by the number of columns when you're putting that in. Now we're going to go to Stats, arrow over to Tests, and we're going down to C, which is the chi-squared test. And Aaron, yours may be in a different spot. I think this is one of those that they've added another test or something in there. So you're doing the chi-squared test is the one you're wanting to do. Then it's asking, where's it at? The observed is the one that you have, where you have put it. If you've put it in matrix A, that's the one that's already popping up. If you wanted to change it, let's say you put it somewhere different because you wanted to keep matrix A. If you're comparing 2 or 3 of these, you might put it in several matrices at one time, and so you want to put them in different places. So where you're observing it from, if you didn't put it in matrix A, to change that, you would go back to second and matrix, and you would just pull it from the name. So here we're doing it from matrix A, so I just hit enter on matrix A. If I had it somewhere else, I would tell it where. Your expected, it's going to calculate out your expected values for you. And so this tells it where do you want it to put that value it's going to calculate. So here I'm putting it in matrix B. You definitely want it somewhere different than what was observed, because you don't want it to type over the top of what you already have. And I think it would give it an error. But it's telling it where to go is what that's doing. So if you already had matrix B, if you had 3 of them that you've already occupied, you might want to put this somewhere different, because otherwise it's going to type over the top of whatever was there. And then just go down to calculate. This is giving me my test statistics. It's telling me my chi-squared value is that 0.798, which is what we found. It gives me my p-value, the probability that I would get this contingency table if these 2 things were independent is a 37% chance that that would just happen by random chance. So that's definitely higher than our significance level of 0.05. If I wanted to see matrix matrix B, we could go to second and matrix again, and we can just go over to edit and go down to number 2, and it gives me matrix B. These are my expected values, the exact same expected values we calculated by hand. I want you guys to be able to use those formulas, so make sure you're able to calculate out the expected value, not just with the calculator. Because I know on the final, I don't have you guys doing the entire problems. A lot of times I'll just ask for parts of something. So I might only ask you, or even on the sticks test, I might ask you just for what is the expected value for winning when the roof is closed. And so you would have to be able to do the calculations out versus just counting on the calculator to do it all for you. Or you could have also just done matrix and gone down to matrix B and just hit enter, and it'll tell us out to lots of decimal places what your expected values would be. Questions? All right, I'm going to go ahead and let you guys write down your homework, and we're going to have a little bit of time to get started on reviewing for the final. Not a whole lot, but a little bit at least. Oh, yes, you've already done 10.3, so just do the bottom. Just do 11.3. Sorry, I didn't make a new PowerPoint since it was just finishing up the one we were already in the middle of. Thanks for noticing that. You're welcome. So I'm handing you the review for the final. So this will give you ideas of problems you might want to start looking over that might show up on your final. The final is, I'm pretty positive it's still 40 questions. I keep forgetting to double check that. I'm pretty sure I got 40 questions. Yes, I do. I've got it written down. Yes. So each question is worth 5 points is basically the way to look at it. So 40 questions, all multiple choice. So the right answer is there. Most common wrong answers are also there. So no partial credit since it's just a quick looking at those. So I'll be able to quickly get your guys' tests graded. So Friday of finals, I should have your guys' grades entered not too long. Before I go home, I'll make myself have your grades finished. You do not have to show work on the final. I will give you some scratch paper that you can use if you want to, but I will not grade your work. Yeah. Oh, you think I'm going to let you use the calculator? Yes, of course I will let you use the calculator. I'm not taking that away from you on the final. That would be mean. Yeah, that would not be nice. No, you definitely get to use your calculator. So, because there's a lot of these, some of it's calculations, obviously, but some of it is just making sure you have an understanding of what's going on type of questions, too. Questions? Okay. Huh? It is going to be interesting. All right, let's start refreshing some of our memories of what we've already done. So hopefully, as you look back through some of these things, that things will look familiar. And I'm definitely not going to cover everything. I've kind of looked at the last several years' questions of which ones are the most frequently missed styles of problems. Most of you guys do okay with those first few chapters. There are some, not matching, they're all multiple choice, but there are some terminology kind of questions. So making sure you are still familiar with some of the terminology, which the first couple of chapters had a lot of the terminology, the types of graphs and that type of stuff. You will not have to graph your own graph because it's multiple choice, and I'm not going to have like 3 different graphs and figure out which one's got mistake type things. So other than knowing that if this is the type of situation, this is the type of graph I would use, is a lot of the main things coming from those. I try to remember if I've got one where you have to read a graph or not. I don't remember. I need to look at you guys' final again. Calculating out from section 3 was finding your different measures of center. So being able to find your mean, median, mode, standard deviation, variance, being able to calculate those, being able to understand what those are talking about. You will still have your reference sheet, yes, with all the formulas that are on there. Now, if you were trying to find mean, median, mode, well, median and mode aren't there, but if you're trying to find your mean, your standard deviation, your variance, what was the trick we used when we were doing that? Okay, we went to stat, went over to calculate, we used one variable statistics, and then you just told it where it was coming from. I don't know if I've got anything in list 1 or not. I obviously did. So go to list 1, and it's going to find the mean of whatever you had in that list that was already there. Remember to put it into your list. We've done that a lot. We're stat and edit, and just put in the list 1, whatever you were looking at there. Then in chapters 4 and 5 is when we really started working with probability and some of the counting, well, mainly chapter 4, I guess, was a lot of the just basic probability. Chapter 5 was our binomial distributions. But in chapter 4, we were working with probability. Because I use this one a lot, how many cards are in a deck? 52 cards in a deck. How many suits? 4 suits. How many cards in each suit? 13 cards in each suit. So we use those a lot. We talked about probability with replacement and probability without replacement. If you've got, we also talked about the difference of when you add and when you multiply probabilities. And what's the difference? How do I decide if I'm going to add my probabilities or if I'm going to multiply my probabilities? Let's see. If I was trying, let me get a new sheet. I was doing the deck of cards and I had the probability that it was a king and a 2. What are we going with? I'm hearing discussion. I'm letting you guys discuss it out before you're going to give me an answer. What is the probability that I get a king and a 2? 1 out of what? No. You guys can talk about it amongst yourselves. Oh, wait a second. I've got something that's impossible to do. You guys should tell me that the probability is 0. Why is the probability 0 in this case? Okay, you're not going to have a card that's both a king and a 2. Yeah, that's kind of more what I was aiming for. So what does the probability of 0 even mean? Okay, absolutely impossible for it to happen. What's the probability that it can be a king and a heart instead? Which makes more sense and was actually what I was calculating out in my head. What is the probability? Go ahead and talk amongst yourselves. Actually, I'm going to leave this one because it's close to time to go. I'm going to let you guys stop and think about when do you add and when do you multiply those probabilities. So add that to your thinking of what you're doing, and hopefully you can figure out what your probability that you get a king of hearts is as you were doing stuff. This is your last homework assignment, yes. Other than studying for your studying for your test and studying for your final. You also have the review worksheet from last time that has your extended problem on that. And didn't I say that's due on Wednesday so that I have time to grade it? Nice try.